Alright, hello everybody, welcome back. It's Carl here again. We talk about my new revised auto top-off system. The last one I had a lot of bugs. I think it was more of code than it was hardware. Anyhow, I kind of scrapped that original design from my previous video and I've moved on to this design. So what this is another one. This is a wireless remote control module. I got this from Walmart or Target. And you plug this in, it has a little remote control that looks like this. And when you push the button, there's a little microcontroller in here that decrypts it and turns on these outlets. So you can turn it on and off. So the first version of this auto top-off I tried to hack the factory remote and use an Arduino to send commands for the buttons. It wasn't very successful. It would work sometimes, but not all the time. And I didn't want it to fail in any one position and dump large amounts of fresh auto top off water into my saltwater system. So the reason why I like this is it's already in a nice compact housing. It already is 120 volts AC compliant, so I know that it's fairly safe. This is actually UL approved for the way it is, so I knew it was a good start in design. And they're cheap. This is like $10. This is an exterior model. I think they have some white ones which are interior, which are even cheaper, like $7.99. So once you open it up, you get this. So the first thing I did was cut off this small little power cord and put my own power cord. This is actually a IEC cable I just cut off, and I wired my own power cable in. You can see this is the factory relay. These are the factory outlets. I didn't do anything on the board, the factory board, except for tie, power, ground, and then the relay activation. Now there's a factory, it's kind of hard to see, but down in the board there's a 78 LO5, 100 milliamp power regulator, and then a transistor, it's like 2N555 or something silly, and that's what activates the relay. So I took out the little microcontroller part, and I put my own Arduino in here. This is a real-time clock module, and I ended up not being able to use the factory regulator. Just didn't have enough power, so I added just a regular 7805 voltage regulator to IC, two little capacitors on that board here, so this is just a 7805. I added a double USB hub, and that's for my float switches. And then I add two capacitors, two fairly large capacitors. This one goes to our Arduino board, and this one filters an additional filter for the incoming voltage. So there's nothing super high-tech going on. The way this circuit works is it takes the 120 volts AC, it has 4 diodes for a bridge refractor, breaks the voltage down to like 20 volts AC, 20 volts DC. That's what they use to run the regulator, and then that's what they use to supply the 78 LO5 regulator to give the MCU power. So nothing super high-tech about this Arduino board. It's just a basic Arduino 16 megahertz clock. All the float switches have 10K pull-down resistors, and I'll show you a schematic of that in a second. And then coming out of the board is raw voltage from the bridge refractor, so it's like 12 volts AC to 20 volts AC, and that's variant. Ground wire, and then there's an output wire, which comes from the Arduino, sends a high, and I used that 10K resistor that they had on the board to activate the factory relay. So I added a real-time clock, and it only allows the system on once an hour, and it runs once an hour for 15 seconds. Here is how I wired. These are the float switches I used. I used a couple of these little just kind of inexpensive float switches. And yes, we're not going to debate whether or not they're reliable. There is some risk with these mechanical float switches. They can fail. Yes, you need to be vigilant. What I do is every time I clean my tank, which is once every 2 weeks, I just clean these float switches with a little brush and just make sure that they stay working properly. So here is the schematic. This is the float switch. One side goes to 5 volts VCC. The other side goes to a digital pin with a 10K pull down, which is what is on this board. So if you don't know, you might be able to see there's actually a magnet, and on this one it's kind of at the top. It's a little darker up top than the bottom, and what happens is you can actually flip these around so that they're normally open and normally closed based upon their position. And the way I have it is when it's down, when it sits in my sump like this, it's down, that means it's low. So when it's low, that means that the switch is high because it disconnects it connects the circuit together, connects this circuit together. So therefore the Arduino pin sees the 5 volts. So it sends a high to the Arduino and it says, hey, I'm low on water, and then it starts the pump routine. And I'll make all the code available. I don't necessarily think that you need these 2 big capacitors. I was having some trouble. Again, I think it was more code-based than it was. I don't program every day for a living, so I'm not the best writer of code. And I think I've got that worked out. So the way it works is if it sees a high from the float switch, that means that it's low in water. And I created a Boolean called water. And if the Boolean is true, that means we're low in water. And then that starts the routine to run the pump. But the other thing I did was I got rid of the delay function. The more and more I get involved with Arduino, I've been playing with it for a little over a year now. I hate delay. It just seems to cause like crashes in my program. So I got rid of delay and now I'm using millis. So it actually every 15 seconds it checks the status of this float switch. So if it's low, if you put your hand in a sump and you kind of splash the water, this float switch might move up and down. Well, before, there could be plenty of water, but because I put my hand in there and splashed it, all I had to do is touch down for a second, and then it says, oh, I'm low on water. So therefore, it would add water when I didn't need it. So now with the 15-second delay, depending upon where you're at in that 15 seconds of millis, it won't do that. You can stick your hand in there. There's a little buffer in now. So it'll run it. The good thing about it is at any time if the water gets high, it's going to shut the pump off regardless. If not, it's going to run that 15 seconds period, and then it's going to lock it out until the next hour. Now, the way I set it up with my RTC is it's going to actually pull the hour time. So technically, if it ran at 5:50, it's going to code it as hour 5. It's not going to decipher to 50. So technically, it could run at 5 and 6. So it really could run within 2 hours. However, with that being said, I only have it running 15 seconds. I have a very, very small pump, as you saw in a previous video, and it can only put in about 25 to 30 seconds. It actually dumps a cup of water in the system. So you're talking 2 cups of water in a minute. So it doesn't make a difference. If it ran twice within 2 minutes, it's going to put a half a cup of water. That's not going to be a big deal for my system. I have a 55-gallon tank with a 20-gallon sump, so I'm probably running 65 gallons of water. If you had a nano tank, that might be a bigger deal, so you might want to adjust the code to run less amount of time. The other thing you could do is I'm using military time. If you got rid of military time, you could almost create the variable to be hour in minutes and set it up that way. So hopefully this will give you some good ideas. And thank you.